Hello friends, this video on classification of elements part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Let's study Debonair triads. So in 1870, this German chemist Debonair, he tried to arrange these elements based on similar chemical properties into groups, and he created 3 such groups, and each groups have 3 elements, and he used to call these groups as triad. So he showed that when 3 elements in a triad are written in the order of increasing atomic masses, the atomic mass of the middle element was almost the average of the atomic mass of the other 2 elements. That's what he told. For example, this is one triad where he has lithium, sodium and potassium. He has put all these 3 in one triad because all these 3 had similar chemical properties. Then he had put this alkaline earth metal, calcium, barium, all these things in one triad because it had similar property. He also put this halogen metals, halogen elements actually, fluorine, bromine, iodine, all these in one triad. So if you see in this case, if you find the atomic mass of this and this, you add these two, 39 plus 7, that is almost 46, divided by 223. You take these also, 137 plus 40 divided by 2, you will get almost similar to 87.6, right? Similarly, 126.9 plus 35.5 divided by 2, you will get 17.9, almost. So that's what he had shown. Relation of atomic mass with you can say properties. Here if you see, these guys all are bucket. There are 3 buckets he made, right? And they are all based on the chemical properties. But he also showed that in this bucket, you take the first and last atomic mass, you add them, divide by 2, you get the middle atomic mass. That's what a relation between, you can say that atomic mass and property of the element, right? This was established. This was never established. First time in 1817 this guy established a relation between atomic mass and the property, right? But there were limitations to this Debonair triads. He could identify only 3 such triads, and that time, please note, 33 elements were known, but still he could find he could fit only, you can say, 9 elements in his triads, right? And these were the 9 elements he fit into the triad. So it was not for all, only for some, but still he showed some relation between the atomic mass and the property, and that's why we studied this. Then this guy came, Newland, and he gave a Newland laws of octave. What he did was he arranged these elements based on the atomic mass. He was not bothered about the chemical property. He was not even bothered about the chemical property, right? He just arranged based on the atomic mass. For example, hydrogen, lithium, beryllium, boron, carbon, all these are arranged in the increasing order of atomic mass. He observed that, and he started with the hydrogen and ended with the thorium. I think that was the 56th element that time. And he observed that every 8th element is similar to the first. For example, hydrogen, fluorine, it was his observation. They had similar property. Lithium, sodium, potassium has similar property. Magnesium, calcium, they have similar property. That's what he observed, right? That was, he observed that they have similar property. So with this, you can see that he found a new thing called periodicity. You can say that, right? Because till now, if we have seen that Debonair, he just found the relation between the atomic mass and the property. This guy found a periodicity of property of the element, right? Correct. And these law he called as Newton's law of octave, because after every 8 it repeats, and it is almost similar to the tune we have, sa re ga ma pa da ni sa, right? Sa re ga ma pa da ni again sa. So it's similar to the tune we have, the rag in the Hindi music. And if you see one achievement of this was, with this, if you see lithium and sodium, right, the property is same. Similarly, beryllium and magnesium property is same, right? So he did all this thing, right? He arranged this all the elements in the order of increasing atomic mass, and then he found that they follow this periodicity, but it had limitations. For example, these are bucketed in one, is also bucketed in one. So there are some limitations which we'll study in the next slides. So the limitation of this Newland's law of octave is like, this guy is applicable only to calcium. So after calcium, whatever the new elements found, they did not fit in his table, right? Only till calcium this was fine. After calcium, the repetition of property was not perfect. It was not perfect, and it was assumed that only 56 elements existed. So please note, he assumed that only 56 elements existed because at that time only 56 elements there, but later on new elements came, right? Chemists discovered a lot of new elements, so, and the new elements never got a space in his table. Also, he adjusted two elements in one group. Example, cobalt and nickel. This is part of one group, right? One group. So this is something which you should not do, right? You're putting in a group, you should have only one element, right? So they're putting, this guy put two elements together in a group. So that was something was questionable by a lot of people. And then also, if you see this iron, it resembles property of cobalt and nickel, if you see, right? But they are so far, correct? Also, if you see, cobalt and nickel and chlorine, they don't have any common property, right? Chlorine, bromine, cobalt, they're all different actually. Cobalt and nickel are metal and chlorine is a non-metal. They are totally different things. But if you see, they are put together. So the placement was not perfect. It had issues. The issues were, if you see the iron and the cobalt and nickel, they are very far, but they have similar property. If you see chlorine and cobalt and nickel, they were together, but they don't have common property, right? And also cobalt and nickel, he has put them together. That is also questionable. So it had a lot of limitation, but again, it showed one thing, that is periodicity of elements property does exist. Maybe the way he found was incorrect, but there is something that can be explored, right? And then we had a new guy that came, but before that, let's go for some questions. The first question is, did Debonair trade also exist in Newland's law of octave? So let's see this. This is my Debonair trades, the blue one, and my Newland's law of octave in the green one. Let's see. Lithium, sodium, potassium. Is it there? Yes, lithium, sodium, potassium is there. That means this guy exists, right? CaSrBa is there. Calcium, SrBa is not there. So this guy doesn't exist. ClBr, chlorine, bromine, iodine. Chlorine is there, bromine is there, iodine is not here, right? So that means this guy also doesn't exist. So if you see, only one triad or only one Debonair triad is part of Newland's law of octave, right? So only one Debonair triad is part of Newland's octave. So the question says, what are the limitations of Debonair classification? As we know that time there were 33 elements known, but not all the elements could be classified in the Debonair's triad. Only 3 triad with 3 elements each. That means you can say that 9 elements were part of his classification, other elements were not part of his classification. That was the limitation of the Debonair classification. The next question says, what are the limitations of Newland's law of octave? So there are no limitation. The first thing, as I told, was only up to calcium he can accommodate, right? That follows the periodicity. After that, there are issues with that. Till calcium things are fine, but after this, it was not following the pattern actually. And the second thing was the new elements which came, right? The new elements which were discovered after that, they were not accommodated. That was one issue, right? And this guy, if you see, right, cobalt and nickel, they were together. That was wrong, right? And if you see, the iron is far away from this guy. Cobalt and nickel is again wrong, and chlorine and cobalt and nickel are in the same group. That's again wrong because they don't share the same property. So that's the limitation of the Newland's law. A, B, C are the elements of Debonair triad. Atomic mass of A is 7, B is we don't know, and C is 39. We have to find the atomic mass of B. So this guy told that atomic mass of B has to be the mean of these two. So that will become 7 plus 39 divided by 2, and that will come out to be 23. And that's my answer. Easy. So this guy told, right? So you have this 3 elements with the similar property, and you create a triad out of that. So the atomic mass of first and the atomic mass of last, you take the mean, you get atomic mass of the middle one. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.